Now here we have another example in 15K on 3 equations and 3 unknowns, which again indicates xyz, 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 that we are looking at 3 planes here. And we would like to know, by solving this system of equations, whether these planes intersect and in what way they intersect. So what we do is we set up the augmented matrix, 2, -1, 1, 5. We detach the coefficients, that's how it's called. 1, 1, -1, 2, and 3, -3, 3, 8. Here's our augmented matrix. Which we can solve by finding the reduced row echelon form on the GDC. You can use elementary row operations by hand, but this of course is much quicker, and if we were allowed to use the GDC, why not? So here we go. I've prepared this a little bit. In the menu 1, the calculation, normal calculation menu, there's this matrices button there, which is F3. You go in there. I prepared matrix A to be a 3x4 matrix, and this is how it looks. It's got all the numbers in there that we need. Let's see, 2, -1, 1, 5, 1, 1, -1, 2, 3, -3, 3, and 8. And to solve the system, I just go back to the calculation menu here. I press Option. I press F2 for matrices, and then the button, the arrow, and the reduced row echelon form is under F5. Then Shift, matrix alpha A, because that's what my matrix is, and execute. And there I've got my answer. Now I'm going to copy that answer, 1007/3. And I hit the 0, 1, -1, -1/3, I believe. Let's check that. Yes. And the last row was all zeros. So here again is my augmented matrix. Maybe I can clean this up a little bit, a bit big. 7/3, like that. Now the interesting part here is that your calculator, although it has an equation solver as well, this method is actually better, because the equation solver will not now know how to handle this outcome here. The all zeros at the bottom. All zeros in one row, that means that we have infinitely many solutions. Infinitely many solutions. Which means these 3 planes here, they do not come together in a single point, because that would be one unique solution. Neither are they parallel, because with parallel planes there would be no solution. So either they are coincident, which means they're completely the same, or they come together in a line. And that's the case that we have here. These planes come together in a line. They're not coincident, because then these equations would be dependent of each other. So A times the first one would be the second one, or K times the third one would be the first one. So what is the solution? Well, x is 7/3. That's a given. And then here we have the dependence between y and z, the dependence between 2 variables, which indicates a line in y and z. So suppose we let y equal t, then negative z would be -1/3 take t. So this one is a t, it goes to the other side, negative t. So negative z is -1/3 take t. Z is 1/3 plus t. And this is the solution. And the interpretation of that solution is that the 3 planes intersect in a line, and a line has infinitely many points, so infinitely many solutions. Let's have a look. Let's do it. Let's go to a 3D graph and let's put in our equations. I'm going to type this in. 2x take y plus z equals 5. 2x take y plus z equals 5. There's one plane, and I will need to put in another one, make it a little bit smaller. You can see what we're doing. The next one is x plus y take away z equals 2. So there's another plane there. And the third plane is going to be 3x take 3y plus 3z equals 8. There's our third plane. Now we want to have a little bit of fun with this. Let's select one and let's give it a nice color. Let's select the other one there and give it another color. So now we have 3 planes, as you can see, and they come together in a single line.